recent developments, China is making significant strides in naval warfare with the construction of its first nuclear-powered aircraft carrier, the Type 4. This ambitious project aims to challenge the dominance of the U.S. Navy's Gerald R. Ford, potentially positioning the Type 4 as the world's most powerful aircraft carrier. This video delves into the unique features of the Type 4, the strategic implications of its development, and the challenges China faces in bringing this supercarrier to fruition. China's Type 4 aircraft carrier isn't just another addition to its navy, it's a monumental shift in global military power. For the first time, China is stepping into the elite club of nuclear-powered aircraft carrier operators, a space only the US and France currently occupy. But why does this matter? Because nuclear propulsion is a game-changer. Unlike conventionally powered carriers, which must refuel regularly, nuclear carriers can operate indefinitely, limited only by crew supplies and maintenance. This means longer missions, global reach, and a continuous presence in key strategic waters, something that has given the US an unparalleled advantage for decades. The Type 4's size alone is record-breaking. It's expected to displace between 110,000 and 120,000 tons, surpassing even the USS Gerald R. Ford, 100 tons. At 330+ meters in length and 83 meters wide, it will be one of the largest warships ever built. This extra space allows China to pack a more powerful air wing, potentially housing up to 100 aircraft, a mix of fighters, early warning planes, helicopters, and UAVs. This boosts sortie rates, meaning more aircraft can take off and land quickly, enhancing combat readiness. A key upgrade in the Type 4 is its electromagnetic aircraft launch system, EMALS, the same technology used on Ford-class carriers. Unlike older steam catapults, EMALS allows for faster, more efficient aircraft launches, enabling China to deploy heavier and more advanced planes like the J-35 stealth fighter. It also means less wear and tear on aircraft, prolonging their lifespan and ensuring they stay mission-ready. Another breakthrough is Project Longwei, China's top-secret nuclear propulsion initiative. This reactor, developed at NPIC, Nuclear Power Institute of China, is designed to power large surface warships for unlimited range and sustained high-speed operations. Satellite images confirm a land-based prototype reactor exists at NPIC's Site 1, signaling that China has successfully developed a naval reactor, something only a few nations have mastered. Aircraft carriers aren't just warships. They are floating fortresses of influence. The ability to maintain sustained presence in global hotspots makes them indispensable tools of military strategy. With the Type 4, China is signaling that it is ready to compete at the highest level of naval warfare. Currently, the US dominates the seas with 11 nuclear-powered supercarriers, each capable of sustaining operations anywhere in the world for months. In contrast, China's current fleet consists of 3 carriers, all conventionally powered. The Liaoning and Shandong depend on fuel resupply, limiting their operational range. The Fujian Type 3 is China's first carrier with catapults, but it still runs on fossil fuels, meaning it cannot match the endurance of US carriers. The Type 4 will change this forever. With unlimited operational range, the Type 4 will allow China to maintain continuous naval presence in the Indian Ocean, South China Sea, and beyond, challenge US carrier groups in the Pacific without logistical constraint, strengthen China's deterrence over Taiwan, as a nuclear carrier could stay in the region indefinitely, extend Chinese influence into critical trade routes, such as the Malacca Strait and Persian Gulf, threatening US and allied dominance over global maritime security. A critical component of power projection is carrier-based aircraft. The Type 4 is expected to house a cutting-edge air wing featuring J-35 stealth fighters, China's answer to the F-35C, designed for low observable operations. J-15T, a catapult-capable variant of China's existing carrier fighter. AJ-600 airborne early warning aircraft, similar to the E-2 Hawkeye, extending battlefield awareness. Unmanned aerial vehicles, UAVs, for reconnaissance, electronic warfare, and refueling, potentially mirroring the US MQ-25 Stingray. This expanded capability will force the US to rethink its Indo-Pacific strategy, A nuclear-powered Type 4 means China can conduct carrier operations well beyond its home waters, making it a truly global naval power. But this move won't go unanswered. The US and its allies, Japan, India, Australia, are already increasing naval cooperation. The AUKUS Security Pact and Quadrilateral Security Dialogue, Quad, are direct responses to China's rising naval power. Building and operating a nuclear-powered supercarrier is a tremendous challenge. The US took decades to perfect nuclear carrier operations. China is just getting started. First, there's the technology hurdle. While China has successfully built nuclear-powered submarines, a carrier reactor is an entirely different beast. It needs to generate massive power output, support high-speed maneuvers, and operate safely for decades. Unlike a submarine, a carrier's nuclear reactor must power EMALS, radar systems, and electronic warfare suites, all while maintaining steady propulsion. Another challenge is logistics and infrastructure. The US operates global naval bases in Japan, Guam, and the Middle East, ensuring its carriers can resupply and repair anywhere. China, in contrast, has limited overseas bases, relying mainly on Djibouti. Without a robust support network, maintaining a nuclear carrier far from home will be a serious obstacle. Then comes training and operations. The US Navy has been operating nuclear carriers since the 2000s, developing a highly specialized workforce of nuclear engineers and carrier aviators. China lacks this institutional experience, meaning Type 4's effectiveness will depend on how quickly China can train personnel to operate it at full combat readiness. Finally, there's the financial burden. Nuclear-powered supercarriers are extremely expensive to build and maintain. The US Navy's Gerald R. Ford class costs around $13 billion per ship. While China benefits from state-funded shipbuilding, maintaining a supercarrier over decades will require significant economic resources. With China's economy facing slowdowns, the long-term feasibility of a full fleet of nuclear carriers is still uncertain. Despite these challenges, China is moving aggressively forward. Satellite images suggest carrier modules are already being assembled at Dalian Shipyard, and its nuclear reactor testing at NPIC is advancing. If China successfully launches the Type 4 by 2030, it will mark a historic milestone in naval warfare, positioning China as a serious challenger to US dominance at sea. The development of China's Type 4 supercarrier marks a pivotal moment in naval history, signaling a shift toward a more multipolar maritime power structure. This nuclear-powered behemoth embodies China's strategic intent to expand its naval capabilities and assert its influence on the global stage. While the Type 4 promises to enhance China's power projection and operational flexibility, it also introduces new challenges and uncertainties. As the Type 4 progresses from blueprint to reality, its impact on international relations and naval warfare will be closely monitored. In this evolving landscape, the world's naval powers must navigate the complexities of competition and cooperation, ensuring that the seas remain a domain of peace and stability. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. And don't forget to leave a comment below.